So folks, the purpose of this next video is to kind of give us intuition for why we'd want to study multivariate functions in the real world. So you can see here that I've got a table, and I got this from weather.gov, and it has a table for converting for determining the wind chill, and you look it up, right? So here you have a collection of input values, and these input values are specifically the temperature outside in degrees Fahrenheit at a particular location. And then you also have another set of input variables or input values for this function, and these are the wind speeds at the location. So what you would do is you would say, okay, let's say I know the temperature is currently 25 degrees and there's a 35 mile per hour wind. What is the wind chill? So you go, okay, let's look at the column that has 25, and you'd look down that column, and then you'd say, okay, well, let's look at the column that has a 30 mile per hour wind. And I might have said 35, but that doesn't matter. That would be that appropriate value. So we know that when the temperature is 25 degrees and the wind chill, and the wind speed is 30 miles per hour, then we would know that the wind chill is 8, and I think that I don't have it specified on here. I think that's usually interpreted as 8 degrees, so that would be like the real feel. It would feel like it's only 8 degrees, even though it's currently 25 degrees outside due to the wind and other contributing factors. So that's how we're going to interpret that. And of course, I think this table should give you a real good intuition of what we mean by those two input variables and then determining the output. But usually with mathematics, we're not going to deal with tables. I mean, we certainly could, but usually in this class, we're going to define our function in terms of some sort of algebraic combination of our input variables. And so here we have the wind chill, which we're denoting with the letter W, in the temperature with T, and the wind speed with V for, think of velocity for miles per hour, how quickly that wind is blowing. And so here we have a real valued function that would go ahead and compute that wind chill rather than looking it up in a table. And where this may be more appropriate is if you wanted to be more precise, like let's say it was 22 degrees outside and the wind speed was 29 miles per hour, you could still determine the wind chill, although I don't know how accurate this particular function is. So let's look at some questions with this. I'm going to leave you guys to do question A on your own, but I'll go ahead and continue with the rest. So I'll let you do letter A. Letter B, so to do letter B, when you do it, you'll use these input values, but I'll go ahead and express this in function notation for the input variables that I picked. We'd have the wind chill, and we did that for I believe it was 25 and 30, and we found out that came out to be 8. So that's what I mean by representing it in that vector notation, or in that function notation. And then I ask you a good question here in C. I'll let you think about that. And then I say express the above question in function notation. So what do I mean by that? So I'll let you read C and work through it, but then for D, if you wanted to ask that as a question, the way you would ask that as a question is to say solve W of TV is equal to, I guess, minus 40. So take a few minutes, get comfortable with this chart. Let me know if you have any questions on that, folks. And what I'd like to do then is let's get ourselves set up to use the CalcPlot 3D script. So I'm just putting this in a video. I've talked about it a little bit in class, but I want to make sure you're able to do it. So I'm asking you to download a particular text file, and then you're going to save it somewhere. I usually save it in downloads, and then you're going to upload that into CalcPlot 3D, and then you'll be able to start working through this script that I built for you. And we're going to do this a lot in the class, so I want to make sure you're able to do so. So let me go ahead and help you out with that. So here I've got pulled up the actual PDF document for this pre-work, and you should be able to see that this is a hyperlink. It links to the Dropbox file. And in my case, it just opened it up. I don't know if that's because I'm signed in or not. regardless, what you're going to do is you're going to have to download it. So over here, somewhere in the right-hand corner, you should see these 3 dots. And I'm going to click that and then go ahead and click download. And in my browser, it puts the downloaded file right here. If I click on it, I think it opens it. And I just want to make sure it's saved someplace where I can find it. So I'm going to hit File, Save As, and I'm going to save it into my downloads file. So there's downloads. It looks like I've already done a couple of versions of this, but I'll hit save. Yes, I want to go ahead and replace it. So you'll save it somewhere where you can find it in a file folder that you know. So then I'll close this. And what I'm going to do now is let's go ahead and click on the link to go to CalcPlot 3D. And it always defaults to pulling up this interesting function here. But I'm going to go ahead and click this menu bar right here in the upper left, and I'm going to go to Scripts, and I'm going to click Load Script, and then I'm going to select that multivariate script that I had you guys just download, and it pulled this up. So we're going to explore this in the next video. You can jump back and forth looking at the various steps of it. You can modify it if you wish. But we'll explore this in the next video. But I just want to make sure everyone could access this script. Let me know if you have any questions doing so, folks.